What is AI observability? AI observability is simply the art of paying attention to how your model behaves once it meets the real world, almost like keeping one eye on your car's dashboard as you drive. All we really do is watch predictions, inputs, and outcomes so we can sense early when things drift off course. Picture a guitar slowly going out of tune, or a city map that ages as new streets appear. That's model drift. Data quality issues are like giving a vision model a smudged camera feed, or handing an LLM slang it never learned. Observability catches these problems before customers feel them. A clean interview answer is, it's continuous monitoring of data, predictions, and performance, so drift, bias, or bad inputs never stay hidden. If they ask for an example, talk about a fraud detector, missing new scam patterns, or a RAG system retrieving outdated embeddings that no longer match fresh documents. Don't worry if this feels new. The more models you ship, the more you'll feel why observability becomes your radar. You're building the instincts of a real operator here. Why AI observability matters. Traditional software behaves the same way every day, but models act more like living organisms that react to whatever data they're fed. That's why a model can feel perfect on day one, yet slip quietly over time, the way a compass drifts off north after long use. Think about a recommendation system that fails when user tastes shift, or a chatbot that struggles when online slang evolves. You can debug normal code with logs, but models produce black box patterns shaped by old training data, so failures often stay invisible. The key message is simple. Without observability, models don't break loudly, they break silently. A strong interview line is, AI systems depend on moving data, so they require observability in a way deterministic code never does. For an example, mention how ride-sharing search models behave differently during holidays, or how content filters at YouTube or TikTok need constant adaptation. Don't stress if this feels subtle. Once you run a model in production, you'll see how fast the world outgrows the training set. Observability is what keeps that gap small. Key AI observability tools. Teams rely on specialized tools because watching a live model is like sitting in a cockpit, where every dial moves at once. Arize gives you a microscope over predictions, letting you spot drift, compare segments, and chase down root causes when a model treats new users differently. Whylabs focuses on privacy-safe data monitoring, which matters when you're handling banking logs or health data. Other options like Evidently or Fiddler help with lightweight dashboards, while platforms like MLflow or Neptune keep track of experiments, versions, and lineage. A confident interview answer is, Arize excels at performance diagnostics, while Whylabs specializes in privacy-first data profiling. If asked when to choose each, say Arize for detailed drift breakdowns, and Whylabs for tightly regulated domains like fintech or pharma. You can also mention that teams running large LLM or RAG systems use these tools to catch hallucination spikes or stale embeddings before they hurt users. Don't worry about memorizing every product name. Knowing the categories already makes you sound senior. The AI observability pipeline. An observability pipeline works like a continuous health check loop that keeps your model sharp. First, you gather predictions, inputs, and labels, just like a doctor collecting vitals. Then you monitor those signals for drift, outliers, or unexpected shifts, the way a thermostat watches changing temperature. When something unusual appears, alerts guide you to the root cause, so you can understand whether the issue came from a feature change, a user shift, a stale model. Finally, you retrain or patch the system, closing the loop and keeping things fresh. Interviewers love asking, how do you maintain a model after deployment? And this flow is the gold standard answer. For examples, mention how Amazon updates demand forecasts after big sales events, or how Gmail adjusts spam filters to catch new attack patterns, or how a RAG pipeline retrains embeddings when a product catalog expands. Don't worry if pipelines feel complex. They become intuitive once you've seen the cycle play out. You're treating the instincts of a production engineer. Common interview follow-ups. Model drift simply means the world changed, but the model didn't. Like following an old GPS in a city that's been rebuilt. You detect data drift by comparing new input patterns with past ones using statistical distance or automated feature monitors. Strong observability also watches accuracy, precision, recall, latency, and data quality, so you know exactly when and where the system starts slipping. When asked about Arize versus Whylabs, the safe answer is Arize is for performance deep dives, Whylabs is for privacy-first data monitoring. A likely follow-up is, which metrics matter most? And you can say it depends on the task. For example, recall dominates fraud detection, while latency dominates chatbots. You can also mention real cases, like an LLM answering poorly when users switch from formal prompts to emoji-heavy text, or a RAG system drifting because its embeddings are months old. Don't worry if this feels advanced. With practice, you'll spot drift and metric shifts the way senior engineers sense code regressions. These instincts come faster than you think. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.